Okay, we are live on Google Hangouts now.
Cool.
So it looked like, oh, I guess I have way too many things open. So there's 18 questions on the quiz for this week. And then when we're doing the homework, it looks like we might need both the qualitative inference Excel spreadsheet as well as the qualitative description spreadsheet. So, yes, going to the quiz now. I trust we all can answer the first two questions.
Yeah, for that one, do you do the y values before or the x values first?
For question...
So do you have number one?
For the quiz, yeah. So the first two, question 1 and 2, those are just true because you're here.
Am I in the wrong quiz?
Lesson 23?
Yeah, mine doesn't have that as question 1.
So yeah, question 1 is like, I've completed the individual preparation assignment. Are you doing the homework assignment or the group meeting quiz?
I'm doing the homework assignment. That makes sense now.
Okay.
Oh, well.
I sent an invite out to the TA. I don't know if she'll be joining us today or not. So.
Okay. I was really confused too. It's like, why did they remove those questions?
Yeah.
But cool.
Those are the easy questions. Just let me know when you have everything up.
Yeah, I got it.
Okay. So honestly, 1 and 2 you can do. Okay, so question 3. I went and I looked in the online textbook, and there's a spot where... what was it? I just saw it. Where was it? Section 4. It talks about it. About the hypothesis test. And so it says the null hypothesis test would be beta 1 equals 0, and the alternative would be beta 1 is not equal to 0.
Okay. So the third one?
Yep. That's what I'm assuming. Okay. So we'll find out.
What are we doing right now?
Lesson 23, group meeting quiz. And then the residual.
C?
Yeah, I got C as well. Actually, just all straight from the book.
Mm-hmm. Yeah, that's what it says in the book. Yeah.
And then number 5. And I remember in the book it said something about patterns, and so the megaphone, like it said that was a type of pattern, and pattern. So I'm thinking it's from there. It means it's either A or B, and you can have residuals that are negative, and so I'm thinking it's the residuals look normal distributed.
So it's 5C.
5. I had 5 as the residuals look normally distributed.
That's what I thought at first, but then I don't see that anywhere in the book. But it does say that there are several patterns that could arise in a residual plot as curvature, megaphone, and outliers.
Mm-hmm. So where is it? Okay, so I'm looking at step item number 3. In order to do hypothesis tests and confidence intervals using regression line, we need to Be sure the following conditions are satisfied. 5 requirements for a linear regression model. There's a linear relationship between x and y. I guess the error term, maybe that's it. The error term is normally distributed. The variance of the error terms is constant for all values of x. The x's are fixed and measured without error. The observations are independent. And then where is it? So many talks about patterns though. So the residual plot shows random scatter. Or this, it's an example, shows random scatter. There's no obvious pattern in the data. If linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there is a pattern in the residuals, then it suggests that regression is not appropriate. And then it lists these are the types of patterns. You can have a curvature, a megaphone, or outliers. And so, at question 5, so megaphone, that's a type of pattern. So C is a pattern and D is a pattern. So we know so it's not those two. Because we're looking for things that support you using the linear regression. Those if we have those
okay.
that says, hey, nope, you can't use a linear regression. It's not gonna work. And then I look at the residuals are all positive.
Sorry.
And then I look at the example they give, and they have negative residuals. So that makes me think.
So they just look normally distributed?
Yeah, they look normally distributed. And then number 6. So number 6, you have to go input that math stuff. The math self-efficacy, it tells you which column to put in what part. And we know you guys are there.
Computers.
No worries.
Very quick. We're still on the linear regression, right?
Mm-hmm. Yeah, lesson 23.
So for this one, which one goes first?
So just to clarify, do you compute it in the quantitative inference procedures in the linear regression?
Yeah, so under linear regression, yeah.
Okay.
And then, the exploratory variable, it tells you on the quiz which value or which row from the math thing goes where.
Okay, yeah, I see how it goes. You have to go reverse. Okay. We want the whatever that is, recentral
Yeah, the residual. So the question is,
Residual.
the residual for the data using software. And what statement best describes the residual? The residuals are between about -40 and 25. The residuals form a linear pattern. The residuals are all negative. I know for sure they're not all negative, so we can get rid of that one. As for the linear pattern,
Is there a summarize on this worksheet that tells are the residual? Because I only see a bunch of numbers
for
residuals on the quantitative inference procedures.
so I can't remember exactly this one. There is one of them where you have to go and make your own scatter plot.
Where are the residuals listed on this Excel calculator thing?
Let me do a screen share with you guys. And, do the whole application share.
Yeah, if you go to the procedures, the Excel worksheet,
Okay, so you got.
procedure is on the fourth column.
So yeah,
Come from the left.
so yeah, I took this stuff from here.
Wait, which one?
So from the math.
Oh, okay, that's better.
So from the math, and then the scores. It says in the directions to put the scores as the y variable, and the other one is the x. And so what I did is I highlighted all the residuals that it calculated. And then I came to insert, and this shows a scatter.
Where you got?
How's that different from the chart they actually give you? Well, I mean, it's definitely different, but like, what's the point of it?
So this one up here, it doesn't have any negative values. This one is not computing.
Okay.
The residuals. It's basically saying, all right, for this x value here, 4.34, put a dot at 50. Okay, so it goes 4.34, 50, boom, puts a dot. So there's not a chart currently.
Okay.
We make one for that plots out all the residuals.
Wait, Corey, you probably plot the number wrong. You probably plot the number wrong. Use the confidence variable as an expansionary variable, which means use the 4.34 that column as the first column.
Yeah, no, that's where it
as
is.
the first.
Yeah, 4.3.
Okay, so number 6 would be the first one then.
And then 4.3.
Oh yeah.
So to the quiz. So yeah, that's what I got because I'm like, oh, it's kind of linear, but not really. There's really not a pattern. But I can definitely say, when I look at the chart, okay, -40 is down
Okay,
here.
and then and then is number 7 also the first one?
And then number 7, I go take a look. Okay, so number 7. So I did a QQ plot. So for that one, I had to open up.
No, because it's a megaphone, so it is normal, right? Because it says residuals are normal if they're like, oh no, it's not a megaphone. I lied.
So anyways, I then took all these values here, copied them over into the qualitative description. I pasted them in here, and then you have to sort it by low to high. And then I look at the QQ plot. And so when I look at the QQ plot, for the most part, they're pretty much right on the line. There's not a whole lot.
Okay, so it's normal.
Yeah, so here they're normal.
Okay.
And so So yeah, it says use the software. So we made the scatter plot, we've got the residual plot, and the QQ plot. And so basically when you say, all right, which of the 5 assumptions about linear regression are satisfied by the data?
Trying to find the assumptions. Okay, there's linear relationship between x and y.
Is it going to be all of them, or has to be all of them?
The error term is normally distributed.
Yeah, because if it's going to meet the requirements for linear regression, it has to meet all 5.
Wait, is that the second one? The variance of the error term is constant for the values of x. Is that the same thing as the error term is normally distributed? Oh no, it's not. Just kidding. So is that okay? So is that number 8 all of them except the middle one? The residuals are normally distributed.
X values are measured without x, y values. That's on x values are measured without error. Yeah. Observations are independent. Yeah. Measure relationship.
Wait.
The QQ plot looks pretty linear, pretty normal.
Yeah.
Should the middle one be true as well?
Okay, so they're all true then, right?
Okay. Well, because that says the residuals are normally distributed. Here it says the error term is normally distributed. So the error term is normally, but I don't know if the error term is the same as the residual.
Okay.
So I figure we'll do that, and I guess we can have someone submit, and we'll find out.
Okay, so number 9 is 12.695.
That comes straight off the Excel spreadsheet. Yes, it did.
Mm-hmm.
Nice. Okay. That's the way I like them. Okay, what is a 95% interval?
Okay, so the lower bound is 10.674.
B1.
Is that right?
This one. So 1060.74.
And then the upper is 14.715.
Where's the number? I didn't see it.
If you go to the Excel spreadsheet, yeah, he's highlighting it on his
Right here.
screen. Yeah.
So it's asking what's the stuff for B1, and then the confidence interval. It gives you the lower and the upper.
Mm.
Based off
The standard of error?
Okay, so for the evidence, so level of significance, so is their p-value higher or lower than that? It is lower.
Where did you find that?
So, oh, no. Okay. So there's our level of significance at 0.05.
Okay.
And over here, it gives us our p-value right here for V1.
Oh,
and
okay.
it's that to the negative 24. So it's
Okay.
super, super small.
See it? Okay. Fail to
Awesome.
reject because it's, no, that's not right. Okay, so it's the last one. Is the p-value is greater, fail to reject the null hypothesis test because the p-value is greater than the
Well,
significance.
the p-value is smaller though. So
Wait.
So it's reject.
This is
It's reject, you're right.
3.312 times 10 to the negative 24. So it's like there'd be like 24 zeros,
Sorry.
or 3 zeros in front of 3. So
Yeah, I just thought we were supposed to fail to reject for some reason. We're supposed to reject it, whatever.
I can never remember half the time what they are. So
Yeah.
okay, so since we reject it,
I don't get why they don't just say like reject or accept.
yeah, because they're stats. I agree with that. That's the hardest part about this class. I'm like, wait, I have to stop to think this out loud. What am I actually doing? So for hypothesis test B1 slope, if you reject the null hypothesis, what does it mean? So if we reject
D, the last one.
that, so there's insufficient evidence to prove that B1 equals 0.
Because there is sufficient evidence, right? To reject, if you reject a null,
Yeah,
there's significant.
Mhm.
And that it's not 0, so it's the last one.
Okay. Oh, body length. Okay, so now we come back to this. Where did I have it? Oh, right there. I haven't opened it. So I have to open up the crocodile thing.
Oh, I don't even need to open it to answer that question. Okay.
Which one's the dependent variable?
So D, because
No, head length is.
we're using head length to predict body length.
So the body length.
So
is
body length
dependent.
is dependent on head length.
Okay, that makes sense.
Cool.
Okay, so that means body length is the y and head length is the x value.
I'm waiting for my Excel to open.
Nice. This one just copy this. If I get it right, what are we looking for?
Okay, and it was asking, so based off the 95,
Okay,
so it's
so
the margin 95, now construct 95% confidence interval for B1. Let's input your answers.
so
for
head
the
length
margin
is
of error.
explanatory.
Okay, so what's the margin of error for? Yeah, head length is I had a head length as explanatory, and the response is the body length.
Okay. That's what I got too.
Okay. Okay, so turn the margin of error for this 95% confidence interval.
What is the margin of error on this? Wait, did you have to calculate the margin of error?
I calculated it there. I'm seeing if there's anything on here that automatically created it. I think that's it. So basically I took, all right, what's the difference between these two and what's the halfway, or what's half of that? So then that means,
Okay, that's how you calculate it? Just those
Yeah.
two divided by 2?
Yep, so that,
That's smart.
yeah, so one minus the other. I did the higher one.
Okay, I'm gonna put that
Is-
in myself. Okay.
So that gives us the total width between the two, and then we take half of that, and
Minus,
that's their margin. So I'll make sure you guys do it so if you get the same number though.
wait, is it 20?
That's the number.
Is it 20.486? No.
Nope. So I was getting
Wait, what did I do wrong?
0.442. So I have M14 minus
You have the wrong
M14.
numbers in there right now.
No, I do.
I think.
The alligator stuff, right? The head
Um,
length, and the body length.
yeah.
Yeah.
Many. Okay, wait. Or am I lying to you? Oh, I'm lying to you.
Okay. Okay. Ooh, that does not look like a valid linear regression though when you look at the scatter plot.
Do you need to create your own scatter
We have
plot?
31.
So that looks like a megaphone to me, but
Oh, I know what I did wrong.
Wait, the scatter plot doesn't look any different than the one we have already.
Okay, so it's 0.442, right?
yeah, that's what I got. Yeah.
Corey, how do you set up your scatter plot for your second one?
The second one.
Put,
Okay, so I just highlighted all this, the residuals.
Mm-hmm.
I went to insert and then just clicked on scatter.
Oh, that's what.
Oh no, I wonder if it's grabbing the stuff from the other. Oh, that's why this one's funny. It's grabbing
Okay,
all the data all
so
the way down to there. So let's get rid of that scatter plot because this is the new one. Okay, and then the lower bound.
it is 7.218.
And the upper bound.
Okay, so I realized what I did wrong with margin error. I was looking for the margin of error for the intercept, not the slope.
Okay.
So double check. The lower bound will be 7.218.
Yeah.
Right?
Yeah.
Mm-hmm.
And then upper bound should be right too.
Okay, and then is question 18 the first one?
CR thing. Yeah, P-value is super small. No, maybe chance not. First one. Yep.
Okay.
Okay, so we're good?
Very quick. What's the answer for 3, 4, 5, 6?
3 is the third one. The 4 is the third one as well.
So I'm gonna go.
And the fifth one is the first one.
So I'm gonna go submit, and we'll see.
Okay.
You guys are working on those. Ooh, yuck.
Did we do bad?
Not as, oh, never mind. Not as bad as I thought. So 10 and 11 we have wrong. Oh, I have 10 and 11 wrong. You guys probably put it in right. I copied and pasted the same number.
What did you put?
Number 8 is wrong.
Number 8?
Yeah, number 8. Okay, so for
Okay, wait, what'd you put in for 10 and 11?
so 10 and 11, I put 10.674.
Mm-hmm.
And then,
That's what I put.
oh, sorry, 10 is right. 10 is right. 11 is wrong. I just
Oh.
copied and pasted the same thing, so I just.
So-
I forgot.
So 11 is 14.715 then?
Yeah, so I probably.
Mhm.
Okay, and then 8 is wrong.
Yeah. Okay, so 3 was C. 4 was C. 5 was A. 6 was A.
7 is B.
How do you create a residual plot?
Which one?
Mm,
The
so
residual?
if you
So the
quantitative inference procedures Excel spreadsheet, when you
Mhm.
put in all the numbers for the explanatory variable and the response variable, next to it, like literally right next to it, it shows explanatory variable and residuals.
Mhm.
With that, you would make a
Scatter plot
scatter
for
plot
each of them.
of those for all of those variables.
So I select all the explanatory variables and then make a scatter plot. Is that how I do it?
Mm-hmm. Yep.
Let me share my screen. It looks like this. Looks super weird. Here you go. Watch this. This is the scatter plot for explanatory variable. How do I interpret this?
which chart did you choose? Doesn't look like a scatter plot.
Insert.
So which
Scatter.
Leo? So which column did you choose?
This one, explanatory variable.
Yeah. No, so you need to do column E.
Oh, residual is right here.
Yeah, so you need to select column E. Yeah, there you go. There, that looks more scatter-like.
My question is, how do I get this?
Yeah. That is the residual plot.
Oh, okay.
So that is it's a scatter plot, but that's what it's called when you do that. Is the residual plot.
Okay. Gotcha. Hot dog shape will be need to see in which chart? This one,
So there's
the
no
original
pattern.
one, or no pattern? That's right.
Yep.
We check the linear relationship by
So linear relationship is good.
variance of all error terms is content of.
So number 2 is good. The normal error term. So we have the second one. The residuals are normally distributed.
Is it?
Is it the fifth one? Observations are independent. What you hope to see is that knowing the value of one of the y's tells you nothing about the other points.
Okay, so it says.
What does that mean?
So there's a linear relationship between x and y. The error term is normally distributed. The variance of the error terms is constant for all values of x. I wonder if that's what we missed. No, that's there too.
I think the fifth one is not right. The fifth
The
one.
fifth one? Okay,
Because you see, the data is describing score and the confidence rating. This, I don't know. These are super related in my opinion, because if you score higher, you generally has a higher confidence.
okay, what about x's are known constants as well? Because it says that x's should be measured accurately and precisely. I don't see how you could possibly do that. Unless there was like a perfect line.
That might be wrong too as well. I don't know. Is that a requirement?
Mm-hmm.
So I know that last.
How do you?
I'm fairly certain
It
the
says
last
x's
one
are
was
known
there.
constants is a requirement.
So yeah, if you
How
go
to
up,
check cannot be checked directly, but what
Just
you
go
hope
up
to
to the
see is
top
x's
again.
should be measured accurately and precisely.
Precise.
it's in
Precise means that you have a standard.
Start of section 3.
I have no idea what these would be, to be honest. Maybe it's number 3 as well, because there's no megaphone. Or wait, no, that's correct. Okay, there's no megaphone.
So if you keep going up, it gives you in a list at the very top of 3 right there. There
It
you
might not be the last 2. So it's only the first 3 that are the answer?
go.
Sounds like good.
That sounds good to you?
Yeah, I'll give it a try.
Well,
Give me.
The variance of the error term is constant.
I got it. I'm
Right.
submitting it.
Okay.
So for sure, 1 and 2.
Missing
And
one.
3. 3 is true. 3 is also right.
Okay.
So it's the first
Yeah.
3 at least.
Thirdly, question A is right. What is question 9 answer?
9 is 12.695. Wait, so we were right. It was just the first 3?
Yeah, number A is right. We're getting that right.
Okay, so you got
So,
the full points for that one.
Okay.
no, I got number 9 wrong,
12.
which is
Oh no, yeah. For question 8.
12.695.
Okay.
these 3 are right. This is the answer of number 8.
Okay. Okay, so the top 3. Move off the bottom 2. Okay.
Okay, I think we're good then.
Okay,
Right.
so question 9 was 12.695.
Okay. Yeah, let me go back and you guys can read me the question answers.
Okay, do you want me to just go down the list and tell you?
Yeah, we'll have Kaylee read it
Yeah.
since Acer hasn't submitted yours. So.
Yeah, okay. Question
Yeah.
3 is the third one.
Then,
Question 4 is the third one.
yeah,
Question
okay.
5 is the first one.
Third one.
Okay.
Megaphone.
Question 3 is C, the third one. Question
And
4
question 3
is
is what?
also C. Okay. Question 3 is the null hypothesis equals 0.
Uh-huh.
And the alternative hypothesis does not equal 0.
Gotcha.
That's the third one. Question 4 is also the third one.
Gotcha.
Question 5 is the first one.
First. Gotcha.
6 is also the first one.
Okay.
7 is the second one.
Okay.
Question 8 is the first 3.
Gotcha.
Question 9 is 12.695.
Mhm.
Question 10 is 10.674. You guys good?
Yep.
Okay. Question 11 is 14.715. Question 12 is the third one, reject the null hypothesis tests.
Okay.
Question 13 is the fourth one, there's sufficient evidence but the regression line is not 0. 14 is the second one, body length. 15 is 0.442. 16 is 7.218. 17 is 8.103. And 18 is the first one.
Okay.
Okay, you guys good?
Yeah, I think we got him.
Yep, got it.
Awesome.
Let's submit.
Oh, yeah. How about just very quick for a final project? I think Core Europe for inference. Hmm? So let us know if you need any help. You can also share the document. We can go over, proofread it.
Yeah, so I'll need to go get your final submission for that last document that you submitted because I think I used some of that to create mine. So.
Okay, so are you guys gonna have me do the last step then? Or are we all doing that one together?
We can all do that together because since we're more familiar with the